Today I want to continue our discussion on parabolas. We've focused at this point in time our parabolas that were functional, where it opened up or it opened down, but I want to also talk about parabolas that open sideways. So let's go ahead and give you a definition, and I'll give you kind of a rundown of what it's going to look like from there. So a parabola, by definition, is a set of all points in a plane that are equidistant from a fixed line we call the directrix, and a fixed point not on that line called the focus. So I'm going to bring in a piece of paper here for just a second and talk about what we see there. So what we have is we have a fixed point called the focus. Somewhere, doesn't matter where it is, maybe there's our focus. And then we have a directrix. Our directrix is going to be an imaginary line. It can be either above or below, or if it's a sideways parabola, it could be on either side of it. We'll do one here where we see it where it opens up. So we know, and we're going to call this the directrix. So a parabola is the points that are equidistant from the focus and the directrix. So one of the points, which we've talked about before, is the vertex. The vertex will lie on that line of symmetry, which is going to go through the focus, and it's going to be equidistant from the focus to the directrix, because we know the distance, equidistance from the focus to the parabola and from the parabola to the directrix. So the distance between here and here is going to be the same. Likewise, if we come out, doesn't matter how far we come out, as long as we're equidistant from the directrix. So we know that this distance and this distance will be the same, and that'll be a point on our parabola. If I come out as well, and we're going to talk about these points here in a second, because we've found these points by plugging them into our equation. Now we don't necessarily need to, because we know the distance from the focus to the directrix can also be the same from the focus out to the parabola down to the directrix, which we'll talk about that in a little while. More importantly, I want you to just kind of get an idea of what a parabola is going to be and the definition of it. So what this means, if I connect those points in a nice curve, if I take from the focus out to my parabola, that distance is going to be the same as the distance from the parabola down to the directrix. And it's always going to be a 90-degree angle with that directrix. So it doesn't matter where we go out here. Again, we can go way out here. This distance will be the same as this distance here. And that's by definition what a parabola is. And what we're going to do today is kind of find the directrix and the focus and our vertex and some other things, domain, range, and that good stuff. So our standard form today is going to be 4p times 1 minus k, or y minus k, equals the quantity of x minus h squared. And that maybe looks a little foreign to you, but I'm going to bring my paper in here again here. If we played around with this equation, this 4p times y minus k equals x minus h squared. If I were to go ahead and solve for y, and that's the form that we've been in before when we talked about our parabolas. We were in y equals or f of x equals because they were functional. So if I divide both sides by 4p, I'd have y minus k equals, let me write it as 1 over 4p times x minus h squared. And if I add my k over, y is going to equal 1 over 4p times x minus h squared plus k. That's the form that we've seen and we've worked in up to this point. This here was our a value, and that told us if it opened up or if it opened down. So what's going to determine this is if p is positive, it's going to open up, and if p is negative, that'll make that fraction negative, so it'll open down. This k value was the y value of the vertex. So if we come up here and look at it, this 4p is going to tell us something about the a value. It's going to tell if it's a positive or negative, so if it opens up or down. It'll also tell us left or right on a sideways parabola. As well, our vertex now is going to be the opposite of what's with x and the opposite of what's with y. Instead of being the opposite of h and the same as our k value, down in this form. So you'll get used to the different forms. If you have questions, please don't hesitate to ask. But we'll go through these, and hopefully it'll make a little more sense as we get into some examples. So, again, our vertex in this form is going to be HK. If P is positive, it's going to open up. And if it's negative, it's going to open down. That P value, very important to us because it's going to identify the focus and the directrix. That P is going to be that distance away from the vertex is going to be the focus, and P away from the vertex is going to be the directrix. If it's positive, we know it opens up, so the directrix will be below it. Likewise, if it's negative, it's going to be above it, and it'll open down, which again we'll talk about a little later. Here, we're going to see that the x value here is not squared, but our y's are going to square. And if I square the y's, that's going to give me a parabola that's going to open up sideways. So we could open up to the left, or we can open up to the right. If our P is negative, it'll open to the left. If P is positive, it's going to open to the right. So without further ado, let's go ahead and look at a problem and see what I'm going to ask you to do with these. And maybe some things will make a little more sense to us. So I want you to identify the vertex, the focus, the directrix, sketch a graph, and then determine the domain and the range of this function. So a couple of things I should notice, or we should notice. The x is squared. Since the x is squared, I know it's going to open up or down. Our p value is going to be in front of the quantity that's not squared. So our 4p, remember from our equation, 4p times y minus k, 4p is going to equal this value out here, so our p is going to equal 1. Since p equals 1, it's a positive, we know it's going to open up. We also know the vertex is going to be the opposite of what's with x and the opposite of what's with y. So our vertex is going to be at 2, 3. So we're going to come over 2 and up 3 units. Since we know it opens up, we know that our focus is going to be 1 unit away from that vertex, and it's going to be up. The focus will always be inside the parabola. Our directrix, we can go ahead and label that, I guess, then. So it's going to be at 2, 4. Our directrix is going to be 1 unit below our vertex. So our p-value, we have 1 unit between the vertex and the focus, and 1 unit from the vertex to the directrix, So our directrix is going to be an equation. It's going to be y equals 2. Now, what we can do is come up with another point. In our other parabolas, we ask you to go ahead and plug in an x value, come up with a y value. You, by all means, can do that. A quicker way of doing that, if you want, take the distance from the focus to the directrix. So we know that p-value is 1, so the distance from the focus to the directrix is 2. What I can do is I can come out 2 units from the focus, and that'll give me my point, because now I'm 2 units away from the focus, and I'm 2 units from the directrix. And I can do that in both directions. And there is going to be my graph. Again, if you don't like that, you can go ahead and plug in a value to the left or to the right of it, and be able to come up with that point. The last thing I want you to find is the domain and the range. Remember, the domain is talking about the x values. So if I were to draw this graph, what values would I need to be able to see this parabola? And my domain is negative infinity to infinity, because I would need all of the x values. My range is the y values. If I wanted to graph just the parabola there, I would need all the values from 3 to infinity, because my graph is up in this region. Nothing's going to occur down in here, so it's not part of my range. So my range is going to start at 3, and it's going to go to infinity. And that's going to be what we're looking for. In example 2 here, we're going to identify, again, the vertex, focus, all that good stuff. So, again, our x is squared. We can go ahead and label that as, or write it as x plus 0 squared if you need, to be able to get our vertex there. So our vertex is going to be the opposite with x. Again, that's 0. The opposite of what's with y, which is going to be negative 1. So we have 0, negative 1 is going to be our point. We know that 4p is going to equal negative 1/2. So if I divide by 4, p is going to equal a negative 1/8. Kind of difficult and ugly to work with, but we can do it. So our p-value, since it's negative, and our x's are squared, we know it's going to open in a downward manner. So we know our focus is going to be 1/8 from that point. I'm going to estimate that value, or that point. I don't need to estimate the value because I know that that value is going to be at 0, and then negative 1 minus 1/8 gives me negative 1 and 1/8, or if you want, negative 9/8. So that's going to be there. My focus, or my directrix, sorry, is going to be 1/8 above that. We'll never cross the directrix as we graph our parabola. So if our focus is below, our directrix has to be above. If our p-value is negative, the focus is going to be below the vertex. So our directrix in this case is going to have the equation y equals negative 7/8, because we're at negative 1, add 1/8 to it, gives us negative 7/8. We can go ahead then, get the distance from the directrix to the focus. So we have negative 1/8 plus, or 1/8 plus another 1/8, gives us 2/8 or 1/4. So I can come out 1/4, and that's going to give me what my graph is. Again, that's kind of an estimation. As long as I see that those points should correlate fairly closely, we'll be good. All right, and then my domain and my range. Again, my domain, my x values are negative infinity to infinity. My range, I'm going to be here at negative 1, and everything's going to be below it. So I don't need, again, anything up in here to be able to see this graph. So I'm going to start at negative infinity. I'm going to come up to negative 1 inclusive. And that gives me what my graph is going to look like. On to one of those that is going to be a sideways parabola. A little more interesting, I think. So here, notice our y's are going to be squared. So it's going to tell us that we're going to be either to the left or to the right. My vertex is still going to be the opposite of what's with x, so 1, and the opposite of what's with y, which is negative 3. So I can go ahead and label that point 1, negative 3. My p-value, I have 4p equals 12, so I know that p has to equal 3. Since it's positive, and my y's are squared this time, it's going to open to the right. So I can come 3 units to the right, and it's going to give me my focus. So my focus is going to be at the point for the negative 3. My directrix is going to be 3 units to the left. So it's going to come through here. And that's going to have the equation x equals negative 2 this time. Remember, I have a vertical line. The equation of a vertical line is going to be in x equals form. I can go ahead and find the distance from the focus to the directrix, which is 6 units, or 2 times the p. So I can come out 6 units. 1, 2, 3, 4, 5, 6 to get my other points. And then 1, 2, 3, 4, 5, 6. Again, this distance has to be equal to the distance down to the directrix. And it's going to be a nice wide parabola. All right, so now my domain and my range. Now we're going to notice the domain and the range are going to kind of flip-flop. So my domain, I'm going to start here at 1, and it's going to be everything to the right of 1 is where my graph is going to exist. So my domain is going to include 1, and it's going to go to infinity. First time we've seen that domain not be negative infinity to infinity, so be careful with them at this point. My range, however, this is going to continue down forever. This is going to continue up forever. So I'm going to have negative infinity all the way to positive infinity. If I wanted to draw this, all of this graph, it would take all of the y values in order to graph it. And that would be the graph of that equation. We have one more. It's going to be another sideways parabola. We're going to see that p-value being negative, though, this time. So our vertex is going to be at negative 7, 2. So we can go ahead and label that negative 7, 2. I know that 4p has to equal negative 5, so if I divide by 4 over, I get negative 5/4. So my p-value tells me that I'm going to open up in the left, or the negative fashion. So I'm going to open up to the left. And my vertex is going to be 5/4 of a unit away from that vertex. So I'm going to be out here. So my focus is going to be at the point, well, we got -7, we got -8 and 1/4, or -33 if you want. But my y value we're going to see is going to be the same. It's still going to be on that too. My directrix is going to be 1 1/4 to the right of that vertex. So it's going to be in the form x equals, so this was at -7, so -6, -5 and 3/4. Or if you want -20/3, I'll accept that as well. For our equation, we can go ahead and double our p-value. If we double that, we get -5/2 or -2.5, or sorry, just 2.5. We're looking for a distance there. So it's going to be about in that form. Again, 2. And again, if you feel more comfortable plugging in x and y values, by all means, you can do that. So there's going to be our parabola. So for our domain and our range, I guess we should have also talked about the axis of symmetry. I didn't put that in there. Our axis of symmetry, I'll go ahead and put that on this one, I guess, because we could ask you that. Our axis of symmetry, again, goes through the vertex. So in this case, it's going to be y equals 2. So my domain and my range. My domain is going to be all the x values from -infinity only to -7. So I'm going to go from -infinity to -7, inclusive with that -7 because I can touch it. My range, if I wanted to graph all the y values, I would need all of them because this goes down forever and this goes up forever. So my domain, my range will be -infinity to infinity. So if you have any questions, give me a yell and we'll talk about it. Join a Zoom or whatnot. Send me an email. Good luck, and we'll see you next time.